Welcome to part 2 of section 8.1. We're going to be talking about completing the square here. We're talking about quadratics. This is kind of the intro to quadratics, so let's go ahead and get started. The first prompt is asking, what do you notice about the following perfect square trinomials? Okay, so each one of these is a perfect square trinomial, and let's see why. So the first one is x squared plus 8x plus 16. That is equal to the quantity x plus 4 squared. Okay, so I want you guys to notice, what do you notice particularly about the 8 and the 4? Okay, and then about the 4 and the 16. There's some sort of relationship here. Okay, moving on. Hope you guys synthesize that information and you can make a predictive guess in just a second. Now we have x squared minus 6x plus 9. Okay, now what's going to be inside this parenthesis? Well, one of the rules you hopefully learned about trinomials, if this middle term is negative and this last term is positive, that means we're going to have a minus sign in between. Okay, I'm going to do it in 2 parentheses just so you guys get the idea. Now, in order to get this 9, we have to have some number times itself twice. Well, that's going to be 3 and 3, and they both need to be negative. And then, how do we get the 6? Well, we get the 6 because once we have the middle term and the outside terms, inside and outside terms, we get 3x, negative 3x, and negative 3x. That gives us negative 6x. So that's just why it works out that way. And of course, we can rewrite this as, I guess I'll write it right here, x minus 3, quantity squared. So what do you notice about this time? It's 3, and then it's the 6 and the 9. So particularly the 3 and the 6, what do you guys notice? Okay, and then the 3 and the 9, what do you notice? Moving on. Hopefully you guys are getting it. One last time. This time we're not going to go ahead and kind of FOIL it out. This time we're just going to figure out why it is the way it is. So we of course know this x. Both the middle and the last term are positive, so this is going to be positive. Now what times itself twice gives us 81? Well, that's going to be 9. Now the question is, does that 9 correspond to this 18x? Yes, it does. What is the correlation? Well, 9 times 2 is 18x. Or 9 times 2 is 18, and then of course we have the x's on there, so that's 18x. 3 times 2 is 6. 4 times 2 is 8. So hopefully you can see that this middle term is double what is inside this parentheses. Okay, and then whatever's inside this parentheses, did you guys figure out what this relationship is between these and the last term? I hope you guys realize that it's times itself. So it's squared. 9 squared is 81. 3 squared is 9. And 4 squared is 16. You can form a perfect square trinomial then to x squared plus bx by adding, what do you add to bx? Well, the pattern was, we took half of 18, we took half of negative 6, we took half of 8. Okay, that was what we put in the parenthesis, right? We put that in the parenthesis, half of 18. Okay, so let's put that, I don't know, let's use blue. Let's give blue some love. So we took half of b, oops, I forgot green. I need to use green. B over 2. Now I would put that in parentheses. What do we do? It just wasn't b over 2. It wasn't 18x plus 9. That's not what the perfect square trinomial was. We are able to put it into a perfect square trinomial with 9 inside the parentheses, but it's not plus 9. What is it? It's plus 9 squared. Where's my pencil? Squared. So we needed to square this b over 2. Okay? So then it's, which equals b over 2, x plus b over 2 quantity squared. And this is equal to that. Okay? That's what I was trying to get at. So inside that parentheses. Now, why is this easier to solve in this form? So if you look at these perfect square trinomials, these aren't really easy to work with. These are easier in this form because it matches what we were doing early in the previous video. In the previous video, we did a problem just like that, where we had a binomial squared equal to 36. And it's easy because we can just take the square root of both sides. Everything's multiplication, so we take the square root, and it makes it a lot more simple for us than in this form right here. This is a tough form to work with. Most of the time we want to get it into factored form, but if we can, perfect square form is even better. Now here's an important note. The coefficient of x squared must be equal to 1 for us to complete the square. So if it's not, you need to make sure you get it equal to 1 by doing some equation manipulation. Here's some great practice. Complete the square in each expression. So using this pattern where we take half the coefficient of the middle term, that's what this is. This is half the coefficient of the middle term, and then squaring it, we can figure out what our perfect square is. Okay, so I'm going to show the first one as 10 divided by 2 quantity squared first. Okay, we take half of 10, well that's 5. We square the 5 and it's 25. Why does this work? Well, because x squared plus 10x plus 25 can be put into parentheses like x plus 5 times x plus 5. That's how you would factor it. Well, if it's x plus 5 times x plus 5, we can just write that as x plus 5 squared. And then we have our answer. Okay, so that's why adding 25 to this expression, which I should write 25 now. Sorry, it's a little messy. That's why adding 25 to this expression makes it a perfect square trinomial. Okay, so now same thing here. We're going to take half of 4, so we're going to do negative 4 divided by 2, and then we're going to square that. So negative 4 divided by 2 is negative 2. We square it and we get positive 4. So positive 4 would make that a perfect square trinomial. We do half of 12, and we square that. Half of 12 is negative 6. Squaring it, we get 36. Okay, then we do half of 14. That gives us 7. 7 squared gives us 49. And that is how you make a complete square. Why is this important? Well, it's important because we are going to use this to solve problems that normally don't appear as they can be solved using traditional methods. Okay, this is like the first step into getting things factored and finding the values of x for quadratics. So first step, step 1, rewrite into ax squared plus bx equals, let me write this in a different color. What's an emphasizing color? Let's see, purple. Equals c. Now, this is different than standard form. As you recall from the previous video, standard form was when it was equal to 0. So why would we want it equal? Where is it? Equal to c. Well, this allows us to complete the square. So we are going to complete the square in step 2. Okay. Now, before I go any further, I think it's best to couple this with an example. So we're going to do both of these at the same time. Okay. So rewrite ax squared plus bx equal to c form. That's our first step. So let's go ahead and do that. So it's not in that form right now. We have this lousy plus 2. So we're going to move the 2 over and get the constant to the other side. What happens? We get x squared minus 4x equals negative 2. Okay, now we complete the square. What I like to do is I don't like to write it all bunched up like this. I like to give some space. And then I like to, if you have the opportunity, use a different color. And you know you're going to be adding something to both sides. So I'm going to write in parentheses up here, add to both sides. Some people forget to do that. Now, how do we complete the square? It's just like we did up there. Okay, we do half of negative 4 squared. Half of negative 4. Let me write this over here to the left. Half of negative 4 and square it. Well, negative 4, that's a 2. Negative 4 divided by 2 is negative 2. Squared is 4. Now, what we do to one side, though, we have to do to the other side. It's imperative that you remember to add to both sides. Okay? So once we do that, now we can simplify a little bit. All right. So we have x squared minus 4x plus 4 equals negative 2 plus 4 gives me 2. Why is this useful? Well, now I know that this can be factored. How can it be factored? Well, it's a perfect square trinomial, which means it's x minus 2 squared equals 2. See why that's a little more useful? That's exactly why this was important. That's why I wrote important next to it and put a star. That's how you know it's really important. Okay, so that was step 3, factored. So we did step 1, check, check, factor, check. Now we're going to find the roots. So this is where we take our square roots. To undo the squared, we get x minus 2 equals, now this is where we need to separate it. We have square root of 2, and we have x minus 2 equals the negative square root of 2. So we have 2 problems. Know that you need to split. So once you say find roots, very important that you, oh, let me write it in orange. Split into whoops, I'm missing a t, I think, into positive and negative. Okay, that's very important. So we're going to find the roots now. Okay, so then we're going to add 2 to both sides, add 2 to both sides. We get x equals, I like to write the constants out in front. I don't like the constants after the radical, because then you might think that's all underneath the same radical. Don't do that. That's like a pet peeve of math teachers. So 2 plus radical 2, it's the same thing. Okay, same thing here. We're going to add 2 to both sides. The procedure is the same, but the answer is going to be a little bit different because we have 2 minus radical 2 for our answer. So x equals both of these things, and we're done. I think that's the last step. We found the roots, okay, and we solved. And that's how you do it. Let's go ahead and do one more, and then we'll save imaginary roots for another video. Okay, this is a real big mess. Notice how we have an x on this side and this side. We're going to try to get these x's all on the left side because the x squared's already there, and then we're going to move this 3 over. Okay, that was just kind of like the big game plan. Let's go ahead and execute. So I'm going to subtract both sides by x. I get 2x squared minus 2x. I'm going to subtract 3 equals, that's 6, isn't it? 9 minus 3 is 6. Now, an alarm should be going off. Look, important. Coefficient must be 1. That's the alarm. Well, it's not. The coefficient of x squared right now is 2. So what do? Well, I got to divide everything by 2 to get rid of it. If there's a coefficient in front of x squared, you need to get rid of it. So let me back this up a little bit. Okay, so I divide everything by 2. I get x squared minus x equals 3. Now I'm ready to rock and roll. I'm going to space this out. Well, let me just take another line. Might as well. X squared minus x plus, let me put this in orange. I like using a different color if possible. Plus this equals 6. And of course, what you do to one side, you have to do the other. We're going to take half of this negative 1 and we're going to square it. Oof, this is going to be a little ugly. So notice how there's a negative 1 there. So we're going to take half of negative 1 and then we're going to square it. So that gives us 1 over 4 because negative 1 divided by 2 is negative 1 over 2. We square it, we get negative 1 squared is 1, 2 squared 4, 1 over 4. So we're going to add 1/4 to both sides. Yuck. Definitely have a calculator handy for this guy. So we have x minus 1/2 squared equals, and then we have, we'll call that 6.25. We'll use a calculator. That's no big deal. Okay, got my calculator. Now, let's, I guess, take this over here, because we're going to take the square root of both sides now. Now, notice that you're going to have to split. We have to split into positive and negative. Anytime you take the square root, now we know we need to split. Whoa, look at all this room to the right. Why didn't I go right? Let me go right. Okay, so I'm going to split over here. So I have x minus, we'll call it 0.5 since we're going decimal anyway, equals the square root of 6.25. And then we have x, I have another one. Let's scoot this guy over. X minus 0.5 equals the negative square root of 6.25. So I just need to add 0.5 to both sides, add 0.5 to both sides, and I get x equals 0.5 plus the square root of 6.25. Now I'm going to get that as a decimal form for you guys. So 6.25, the square root of that equals 2.5. So 2.5 plus 5 is 3. So you get x equals 3. Okay, then I have for the second one, add 0.5 to both sides. I get x equals 0.5 minus square root of 6.25. Again, I take that, I get 0.5 minus 2.5. That's what this square root equals, by the way, in case you didn't figure that out. Equals, and that will give me negative 2. And so x equals negative 2 and x equals 3, and those are my answers. Well, I'll see you next time when we do our third part of this video, which is imaginary roots. See you then.